Okay, problem 3 and 3.5. This is the last one of this section and transformations. Notice the background is still the same. Basically, you're graphing with your transformations. This is what you've got. Your parent function is the x cubed, and this is y equals x cubed right here. And what all's going on? Well, it's horizontal to 3 units to the right. There's no stretching or shrinking. This negative out front flips it over the x-axis, and then you shift it up forward. So let's actually look through this and see what all is going on. All right, so you begin with that. The first thing that you take care of was that minus 3 that was right there, the x minus 3 cubed. You move it right 3 units. Notice it went from 0, 0 to 3, 0 is what happened. That point was shifted just like every other point. No stretching or shrinking. Reflecting. The negative in front of the x minus 3 out here. This is where you see this negative out in front. It flipped from starting low, going high, to going high, going low. It reflected over the x-axis. The point 30 did not change, but all the other points would have changed. That's your anchor point. Then you had a vertical translation, the up 4. So we've done everything but slided it. We'll slide it up 4, and the point that started out at 0, 0 is now 3, 4. We reflected in the x, and we moved up 4. Your actual MyMathLab problem uses this format. The first thing you'll do is choose the cube, and then you'll kind of click, and it'll give you the basic y is equal to x cubed, and then be sure you do these in order here. You have a horizontal shift to 3. You move this little thing right here till it's at 3. And then you reflect it in the x-axis, so you click here. And then your vertical shift up 4. It would start at 0, and you would just move that to 4. Then you save it and check it. Its domain is all real numbers. Its range is all real numbers. When you're dealing with the odd-powered functions as a whole, your domain is going to be all real numbers, and your range too, because it's going to keep going. Your line sometimes is the only one, the power of 1. Okay.